Welcome to Career Point. For today's video session, we will discuss types of resistors. The resistors are mainly classified into two types, that is fixed resistor and variable resistor. Then question is, why it is called fixed resistor? It is called fixed resistor because its resistance value does not change with the change in voltage or temperature. If it is ideal fixed resistor, then it provides constant resistance under all environments. But if it is a practical resistor, then its resistance value varies slightly with increased temperature. So most frequently used resistance values of fixed resistors are 10 ohm, 100 ohm, 10 kilo ohm, 100 kilo ohm. These are the symbol of fixed resistor. Then next question is, why it is called variable resistor? It is called variable resistor because its resistance value changes. It is used to control the current and voltage value of a circuit by adjusting the resistance value. The resistance value is varied by sliding a wiper contact along with a resistance track, or the resistance is adjusted at preset value as required at the time of circuit building by adjusting screw attached to it or by controlling the knob connected to it. These are the symbol of variable resistor. So as compared to fixed and variable resistor symbol, a fixed resistor has two terminals, but a variable resistor has three terminals. That is, two terminal is fixed terminal and another terminal is variable terminal. Then these are the types of fixed resistor and variable resistor. The fixed resistors are carbon composite resistor, carbon film resistor, wear wound resistor, metal film resistor, metal oxide film resistor, and the variable resistors are rheostat, potentiometer, thermistor, varistor, photoresistor. First we discuss carbon composite resistor. The carbon composite resistor is the most commonly used resistor in earlier days, but nowadays a carbon composite resistors are rarely used because its high cost and low stability. The carbon composition resistor are also called carbon composition or carbon resistors. The carbon composition resistors are made up of from solid cylindrical resistive element with embedded wire leads or metal end caps. The cylindrical resistive element of the carbon composition resistor is made from the mixture of carbon or graphite powder and the ceramic. The carbon powder acts as a good conductor of electricity. The solid cylindrical resistive element is covered with plastic to protect the resistor from outside heat. The leads made up of copper are joined at the two ends of the resistive element. The resistance of the carbon composition resistor depends on the amount of carbon added, length of the solid cylindrical rod, and the cross-sectional area of the solid cylindrical rod. Then the resistance of the carbon composition resistor is inversely proportional to the amount of carbon added. That is, we know carbon is a good conductor of electricity. Hence, if the more amount of carbon is added, then more amount of electric current flow and only a small amount of electric current is blocked. Thus, the carbon composition resistor with more carbon has low resistance. If less amount of carbon is added, only a small amount of electric current flow and more amount of electric current is blocked. Thus, the carbon composition resistor with less carbon has more resistance. Then, The resistance of the carbon composition resistor is directly proportional to the length of the solid cylindrical rod. The cylindrical rod with a long length provide high resistance to the electric current because the free electrons have to travel a large distance. Then the cylindrical rod with short length provides low resistance to the electric current because the free electrons have to travel only a small distance. Now, the resistance of the carbon composition resistor is inversely proportional to the cross-sectional area of the cylindrical rod. If the cylindrical rod with large cross-sectional area provides large space for the free electron to move freely, hence the possibility of collision of free electrons with the atoms is low. Thus, a large amount of electric current flow through the carbon composition resistor. Then, what is the advantages of carbon composition resistor? The major advantages of carbon composition resistor is its ability to withstand at high energy pulses. The cost of carbon composition resistor is low. Then, the disadvantages of carbon composition resistors are: it has poor stability, it generates high noise, and it has low accuracy. The most common problem occurred in carbon composition resistor is water absorption. When the carbon composition resistor absorbs water, the resistance may increases or decreases. Then what are the applications of carbon composition resistor? You remember there are various applications of carbon composition resistor. That is, it has applied in current limiting, it applied in protection of circuit, high voltage power supply, welding controls, and the carbon composition resistor are used in high frequency applications. Then come to carbon film resistor. The carbon film resistor is made by placing the carbon film or carbon layer on a ceramic substrate. The carbon film acts as the resistive material to the electric current. Hence, the carbon film blocks some amount of electric current. The ceramic substrate acts as the insulating material to the heat or electricity. Hence, the ceramic substrate does not allow heat through them. Therefore, this resistor can withstand at a higher temperature without any damage. As shown in the figure, here also metallic end caps are fitted at both the end of the resistive material. The leads made up of copper are joined at two ends of these metallic end caps. The resistive element of carbon composition resistor is coated with epoxy for protection. The resistance of the carbon film resistor depends on the thickness of the carbon film layer and width of helical carbon film cut. The resistance of the carbon film resistor are more preferred over carbon composition resistor because the carbon film resistor produces less noise than the carbon composition resistor. The carbon film resistor have low tolerance value than the carbon composition resistor. The tolerance of the resistor is the difference between our desired resistance value and the actual manufactured resistance value. The carbon film resistors are available in the range of 1 ohm to 10 mega ohm. The carbon film resistor has high negative temperature coefficient of resistance. That is, the rate at which the resistance of the material decreases with increasing temperature is called negative temperature coefficient of resistance. The carbon film resistor have a high negative temperature coefficient of resistance. Hence, the resistance of the carbon film resistors decreases easily with increasing temperature. We can use a carbon film resistor in X-ray, in power supplies, and in radars. Then come to metal film resistor. The metal film resistor construction is similar to the carbon film resistor except that the material used for constructing the film is different. In carbon film resistor, carbon is used to construct the film, whereas in metal film resistor, tin and antimony or nickel chromium is used to construct the film. The metal film resistor is made by placing the metal film on a ceramic substrate. The metal film resistor resists the electric current flowing through it. Hence, it acts as a resistive element to the electric current. The ceramic substrates do not allow heat through it. Hence, it acts as an insulating material to the heat. The metal film resistors are more preferred over carbon composition resistor because the metal film resistor generates less noise as compared to carbon composition resistor. The metal film resistor have low tolerance value than the carbon composition resistor. The difference between our desired value and the actual manufactured resistance value are: if in a metal film resistors the desired resistance value is 300 ohm, then actual manufactured resistance value is 302.4 ohm. In metal film resistor, the desired resistance value can be achieved by either trimming the thickness of metal layer or by cutting the metal film in a helical manner along its length. This is generally done by using the laser. A metal film resistor has low temperature coefficient of resistance. The rate at which the resistance of the material changes with change in temperature is called temperature coefficient of resistance. The resistance of the metal film resistor depends on thickness of the metal film layer and the width of the helical metal film cut. The metal film resistor is applied in the high frequency application. Then come to metal oxide film resistor. The construction of metal oxide film resistor is almost similar to the metal film resistor. The main difference between the metal oxide film resistor and metal film resistor is the material used for constructing the film. That is, in metal film resistor, the film is constructed by using the metal such as nickel chromium, whereas in metal oxide film resistor, the film is constructed by using the metal oxide such as tin oxide. The metal oxide film resistor is made by cutting the ceramic core with metal oxide such as tin oxide. The antimony oxide is added to the tin oxide to increase its resistivity. The resistivity of the metal oxide film resistor is mainly depends on the amount of antimony oxide added to the tin oxide. Then come to the wear wound resistor. The wear wound resistor is made by winding the metal wire around a metal core. In wear wound resistor, metal wire is used as the resistance element and the metal core is used as the non-conductive materials. Nichrome or manganese is commonly used as the metal wire because they provide high resistance to the electric current and operate at high temperatures. The most commonly used core materials are plastic, fiberglass or ceramic. The resistance of the wear wound resistor depends on three factors: resistivity of the metal wear, length of the metal wear, and cross-sectional area of the metal wear. If the resistance of the wear wound resistor depends on the resistivity of the metal wear, it is directly proportional to the resistivity of the metal wears. A metal wear with high resistance draw large amount of electric current. Therefore, wear wound resistor provides high resistance to the electric current. The resistance of the wear wound resistor is directly proportional to the length of the metal wear. If the length of the metal wear increases, then the resistance of the metal wire wound resistor is increases. Then cross-sectional area of the metal wire. The resistance of the wire wound resistor is inversely proportional to the cross-sectional area of the metal wire. The metal wire with small cross-sectional area provides less space for the free electron to move. Hence, the possibility of electrons collision with the atoms is high. Therefore, only a small electric current flow through the electric wire wound resistor. And the metal wire with large cross-sectional area provided enough space for free electron to move freely. Hence, the possibility of electron collision with the atoms is low. Therefore, large electric current flows through the wire wound resistor. Wire wound resistor are classified into two types, that is power wire wound resistor, precision wire wound resistor. The wire wound resistor are widely used for various applications, that is in telecommunication, in computers, audio and video equipments, medical electronics equipment. It also used in defense and space, telephone switching system, transducer and instrumentation, current and voltage balancing, current sensing. Then we discuss about variable resistance. The first variable resistance is rheostat. Rheostat is otherwise known as adjustable resistance. It is used in application that requires adjustment of current or varying of resistance in the electric circuit. As you seen in the figure, a rheostat has three terminals. There is terminal A and terminal B are fixed terminal, and terminal C is variable terminal. Then comes potentiometer. A potentiometer is otherwise known as a pot. In electronics technology, is a three-terminal resistor with a sliding contact that forms an adjustable voltage divider. Potentiometers are commonly used to control electrical devices such as volume control and joystick, etc. As you see in the figure, the potentiometer has also three terminals, that is terminal 1 and 3 are fixed terminal and the terminal 2 is variable terminal. Then comes the thermistor. What? Thermistor means a thermoresistor. Its resistance value changes with change in temperature, so it is called thermoresistor. The most of the thermistor have negative temperature coefficient. They are normally made up of semiconductor materials. A resistance up to a few mega ohms can be obtained from the thermistor. They are used to detect the small temperature changes. When there is a temperature changes, however small, there will be a large change in value of the resistance. Then come nonlinear resistor or varistor. The varistor have nonlinear VI characteristics curve. Why? Because this type of resistance is not obey Ohm's law. They are made up of materials such as silicon, carbides, zinc oxide. There are three types of varistor, that is silicon carbide disc type varistor, silicon carbide rod type varistor, zinc oxide type varistor. Then come photoresistor. A photoresistor is otherwise known as light dependent resistor. It completely depends on the intensity of the light falling on it. This is made up of cadmium sulfide, which contains a small number of electrons when it is not illuminated. When a light ray falls on it, electrons get ejected and hence the conductivity of it increases. Hence, it offers low resistance when light falls on it and offers high resistance in the dark.